I welcome you all in this presentation related with the subject materials processing fundamentals and practical. Here onwards we will be talking about the various practical related aspects of this subject. So, which will include the conducting the different demonstrations as well as doing the different experiments for development of the say the job for by casting, by welding, rolling and likewise. Then initially what I will be doing in this particular presentation, I will be talking about what we are going to learn from this particular the practical and the lab demonstration. So, what it involves basically as far as content is concerned, we will try to see for the casting what we need making the pattern first. Okay. So, wooden pattern will be made. So, what we need for that different tools as well as the wood. Okay. Then once the pattern is made, once the pattern is available, this pattern will be used for making the mold. Okay. So, we will be making the sand mold. So, the different tools, equipment and sand preparation which is used for making the molding sand ready for preparing the sand mold, we will be trying to learn about the preparation of sand mold. So, getting the molding sand ready and use of the various terms related to the molding and sequentially steps which are used for preparing the sand mold. And once our mold is ready, then what we need? We need to prepare the molten metal. We need to obtain the molten metal. Okay. So, we can use the suitable metal as per the furnace or the heating facility which is available. It can be aluminum, cast iron, lead, anything that we can melt will be used here. So, here we will be using the lead and we will be using the pit furnace for melting the lead, and once the molten metal is obtained, the suitable fluxes can be added for cleaning and removing the impurities. Okay. So, melting of the metal, after the melt treatment it is poured into the mold. Mold we have already prepared and then we allow the molten metal to solidify. So, once it is solidified, then the casting will be obtained. So, the casting initially will have like various components, say for example pouring basin, sprue, riser, apart from the main casting. So, these other undesirable components which are there in form of the solidified metal, those need to be removed. And then we will be trying to take one case study which will be involving like development of the three types of the cast aluminum silicon alloys, say aluminum 4% silicon, aluminum 12% silicon and aluminum 20% silicon. So, these are the three types of alloys, because the eutectic in aluminum silicon alloys is formed at 12% of the silicon level. So, aluminum 4% silicon will be falling under the hypoeutectic aluminum silicon alloy. Okay. While the aluminum 12% silicon will be an eutectic aluminum silicon alloy, and the last one having the 18% silicon will be hypereutectic aluminum silicon alloy. Okay. So, these three types of the alloy with the different content of the aluminum 4 to 20% silicon, say 0.3% of the Mg. These will be prepared, you see, initially using the suitable pure aluminum and suitable master alloys of the aluminum and silicon and aluminum and Mg. Using these master alloys, the desired composition is obtained and it is these are melted. So, the molten metal is then after the suitable melt treatment as per the case, say for aluminum 4% silicon, the grain refiner will be used ALTIB. Okay. And for this eutectic aluminum silicon alloy 12% silicon, strontium will be used as a modifier, and then aluminum 20% silicon, the phosphorus will be used as a refiner. So, these are the kind of the additional the melt treatments which will be done for obtaining the desired micro structure. So, now once we develop these three castings, they will be studied for the development of the microstructure as well as mechanical property in terms of the hardness using VHN, Vickers hardness number. Okay. So, how the variation in the silicon content is affecting the different constituents. So, affecting the microstructure as well as it is affecting the hardness of the casting. So, what we are going to learn from this particular experiment and demonstration related with the pattern making, molding and casting, to learn the stages of making the pattern, mold and casting. Now, to know the use of various tools and equipments which are used for making the pattern, molding, sand mold and casting. And thereafter also one more important aspect that we will be studying is the effect of silicon content on the microstructure and mechanical properties of the casting, which will be obtained through the die gravity casting. Okay. So, for making the pattern, what we need? Okay, we need seasoned wood. Okay, and the different tools for removing and finishing the pattern, that will be done in the carpentry shop. Then the suitable greens and moisture, means the water and the binder will be used, okay, for preparing the molding sand. Then using various tools which are used in the foundry, the sand mold will be prepared, okay, and this sand mold will be used later on for the casting purpose. Then the lead will be used as a metal, and then this will be melting of the metal in the crucible, suitable graphite crucible using pit furnace. Okay. So, the pit furnace using suitable graphite crucible, and once we have the molten metal, then with the help of the ladle, molten metal is transferred and poured into the sand mold that has been prepared. Okay. As far as the demonstration is concerned, we will also be talking about the methods that will be used for making the three types of the aluminum silicon alloys, and so the development of casting, that is one, and the characterization, how the things alloys were characterized. So, the casting in this particular case for the lab demonstration, casting of aluminum or lead etc., as per the facility available for the melting can be used.
Hello everyone, Namaste and welcome to our carpentry shop. I am removing my mask for better audio communication. So this is our carpentry shop, and here we are going to perform jobs on the wood itself and going to prepare certain patterns. So before moving further, let's have introduction to various tools used in the carpentry shop. Now look at these various tools used in carpentry shop. We have jack plane, smoothing plane, mallet, crosspin hammer, chisel, various types of chisels. Then we have marking gauges, screwdriver and various types of saws. So now you can see here job which has to be prepared by the students. This is half lap center joint. Here you can see various jobs which can be produced in this shop. You have various T joints, then king post truss, scarf. You can produce various types of jobs in this carpentry shop. So you can look at these two jobs. These are to be produced by the first year students. These are to be done by second year student, plumber block and this. So coming to this again, these equipments and tools you are going to use. This is jack plane, this is tri square, this is scale, rule, saw, marking gauge, mallet, chisel, and this is polish paper, of course, bench, hook, and this job will be now prepared by Yogendra ji in the carpentry shop. There are different types of woods, so this wood is used, and most of the time patterns they are made up of wood only. If it's there 45, then 125 mm, 125 mm. With the help of scale, markings are done. transfer लेंगे. Transfer is being used. छुट्टी ऊपर रखेंगे और 10 इंच से यहाँ. Extra material being ये दो पीस है, एक में से ये बनेगा और दूसरे वाले में से दोनों की मार्किंग करनी. As per the scale, marking has to be done for further cutting. लेंथ के सेंटर में निशान. दूसरे पीस की जो विड्थ है के सेंटर में as per drawing marking. इसकी विड्थ का निशान इसके सेंटर में लेंगे, दोनों को यहाँ मिलाएंगे. एक निशान इधर और एक इधर. राइट पैर से तीन साइड में लेंगे निशान. इसकी विड्थ का निशान जैसे ये काटा है एक साइड में, इस तरह से यहाँ लगाएंगे. इसकी विड्थ का निशान ये राइट पैर से तीन साइड. जो इसकी थिकनेस है इसके सेंटर में निशान लगाएंगे. ये 26 mm है, 13 mm पहले ये मार्किंग ये सेट करेंगे हम अपना. इसके ऊपर इसको निकालने के लिए पहले यहाँ से इसको 10 इंच से काटेंगे. कैसे यहाँ से लाएंगे, बीच में निशान लगेगा इधर से. चीजल का काम है. So now you have to hold this job in the with the help of chisel. Side and again start cutting with इसमें केवल 10 इंच का काम है. इसको यहाँ ऐसे बांधेंगे. जो निशान लगा है Dear friends, look at those charts. Various carpentry tools used in carpentry shop, they are shown there. Various chisels, then various braces, then various holding devices. Then you have various carpentry measuring tools, then marking tools. Already we used one marking tool. Then various joints used in carpentry. Then planes, commonly used is jack plane, wooden jack plane. Various parts they are shown there. Then again various carpentry joints they are shown there. Then various hand tools used in the carpentry, they are also shown there. And lastly, various pipe fittings, they are shown in that figure. We have to produce this wooden handle as well as this flange pipe, but right now we are going to have a demo of this wooden handle. Then you can see various equipments. This is woodworking lathe on which you are going to produce that wooden handle. This is grinder. Various wood turning tools, they are being used: gauge, round nose, flat nose, parting, skew and spear point. Then you can see various equipment. This is drilling related operations can be performed here. You can have an overview of this entire carpentry shop. Various machines they are being arranged. This is one cutting machine. This is another cutting machine. So you can see grooves of this kind can be produced on this machine. Then we have another cutting machine here, and we have one saw, continuous cutting saw machine here, hand saw. This is woodworking lathe machine. The lathe machine in the machine shop you might have studied in MIN 104. This is on a similar concept. This is woodworking machine. This is the bed of this machine. This is a tailstock which can move forward and backward. Here you can hold the tool. This is spindle in which you are going to mount the job. And these are various tools used in this job. Now Yogendra ji will help us to demonstrate the practical. This wood is stone and will be used to produce a pattern. So marking the center, so mark diagonally to get the center on both the ends. This centering is done in order to have job in true rotation. So you can see job is mounted on the spindle. Another end is fixed at the tool stock. Now machine has started.
Round nose tool.
First we use round nose tool to make a round.
Dia 30 mm.
We need to maintain dia 30 mm, so it has to be pre-adjusted in this caliper. Stop the machine and check. So it is not achieved, so further you need to machine it. So now it's passing, now dimensions are achieved. So this is for smooth cut.
मार्किंग करेंगे
Then we need to mark.
125 पे बैलेंस है 125 पे डाया 23 में बीच में से 23 रखेंगे ऑलमोस्ट
Now again adjust the caliper to 23 diameter.
फ्लैट नोट को लेंगे यहाँ से तो सीधा करेंगे
Again check the dimensions.
फ्लैट नोट को लेंगे और पूरा total length is
Mark for 140 mm and cut the remaining portion
parting tool
with the help of parting tool. With the help of polished paper, make the surface finish good.
यहाँ से कट जाएगा
Now this
Complete drawing नहीं
job is done. This has to be cut from, this much portion has to be cut off, and this job is ready. This wooden handle is ready. Dear friends, welcome back. I am Dr. Almoik. Welcome to our foundry shop. Here in these charts you can see various types of patterns which can be used, and you can see various foundry hand tools which you are going to use in the foundry shop. Then another set of tools. Then we have this centrifugal casting process. This will be discussed in the class in the details. Then we have this blast furnace, then cupola furnace and electric arc furnace. These three furnaces basically they are used to melt the raw material which is poured into the mold cavity. Here you can see these are the benches on which practical is being conducted. So these are boxes, these are various tools. This is the actual sand which are going to use. This green molding sand because it contains moisture or let's say water content. So that's why it is called as a green moisture sand. And these are flasks. This scope, bottom one known as drag, and in which you are going to place the pattern and you are going to use sand. So this arrangement is known as full proofing arrangement, where you get the exact matching of scope and drag. He is our Balesh ji, and he is going to demonstrate how to prepare a mold cavity with the help of this pattern.
पैटर्न का नाम हाफ बेयरिंग है.
Half bearing pattern.
This process bench molding process.
This is known as a bench molding process because everything is placed on the bench and you are going to work on.
Molding box.
This molding box, upper one is scope, lower one is drag.
Molding board.
This is molding
Board.
board on which you are going to place everything. So you have to keep drag box in inverted position, then place the pattern inside the drag like this. Then start pouring the sand. First we are using parting sand.
Dust. Parting sand.
So you need to dust the parting sand, then use this green sand, pour on the pattern. Till drag box is full.
Pin jammer.
This is pin rammer. You have to ram the sand. Extra sand again goes to this ground below and it can be reused again and again. So again pour the sand. Again use this pin rammer and start ramming. Again you put some extra sand.
Flat hammer.
This is flat rammer. You need to level the sand. Extra sand again can be reused. This is straight edge, with the help of which you can remove the extra sand. Like this. So again use parting sand. So some vents are to be created in order to allow the gases to escape into the atmosphere. This can be done randomly. Drag upside down. This tool is known as smoother.
Surface is smooth.
To smoothen the surface. Cleaner. So in order to remove the extra sand from the mold cavity, you can remove this extra sand from the mold. Now you need to have a sprue and runner. So these positions are marked. Again we are using parting sand. Then put a cope on the drag. Again pour the sand into cope box. Place the runner. Fix the runner, then sprue. Pour the sand. Fix the position of sprue. The help of hands, with very gentle forces are to be applied. Then start pouring the sand into the cope box. Make it even. Again use pin rammer for ramming. Same process has to be repeated again. Pour the sand again and again. Till cope box is full of sand. Again put extra sand. Then leveling with the help of flat rammer. Using straight edge, remove the extra sand. Then please dust the parting sand again. Venting has to be done again in both cope and drag. Then remove this wooden pieces used for making runner and riser.
Silica. This is the pouring cup.
Now we are expanding it for a pouring cup. Again for riser, we are shaping the riser.
उसके बाद सर ये ऊपर वाला को उठा के बेंच को
Then cope has to be removed and keep it upside down. You can see the pattern still there. The pattern has to be removed. With the help of this arrangement, pattern has to be removed gently. The pattern is removed without damaging the mold cavity.
जहाँ इसको
Now, since this is not a complex pattern, we can make the gate manually. Otherwise, in complex products, gates are every gating system is itself made on the pattern. But here you can do it manually, since pattern is not that much complex, or the workpiece is not, final product is not that much complex. Remember one thing, you have to do it very gently. You cannot damage this walls of mold cavity. For pouring, you need to dust chalk powder in order to get better and better surface finish. Then you close the mold cavity by placing cope on the drag box. Now you can see this entire mold box is ready for pouring. So material is used, lead. Now this molten metal is ready. So this is our crucible in which you are going to place raw material. In this case we are using lead as a material. Lead will be placed here, and this entire crucible with the help of tongs will be placed in this pit furnace, and material will be melted, and material is ready for pouring into the mold cavity. So we have blower here with continuous supply of air, keep in hot condition. Now molten metal is being poured into the mold cavity through pouring basin. It goes into sprue and into the mold cavity. You can see a riser is also being filled. Now molten metal will solidify since heat is being absorbed by the mold wall and entire mold, and we have to wait for solidification. Once it is solidified, you need to break this mold, you get the casting. Now metal is solidified, we need to break the mold. Just remove the cope. You can see here this drag casting, you can see here. Simply you have to break it. So remove the now we need to clean the casting. So your casting is ready. You can see the riser and sprue. Now you need to clean the casting with the help of brush. That sand has to be removed. So this is extra material which has to be cut, and this is our casting. So casting is ready for further machining in machine shop. So our casting is ready. Runner and riser that is being removed, and this casting will go to machine shop for further machining. Since we use so many allowances, shrinkage allowances and machining allowances on this pattern itself, so extra material in terms of material is provided on the pattern itself, and that has to be taken care.
Now we have seen the method of preparing the pattern, preparing the sand mold, and making the casting. Okay. So in this particular case study, what we have done is we have taken developed the three types of the cast aluminiums, silicon alloys, say aluminum 4% silicon, 0.3% Mg, aluminum 12% silicon and 0.3% Mg, and aluminum 20% silicon, say 18% silicon and 0.3% Mg. These were prepared by controlled melting of a high purity aluminum and aluminum silicon master alloy with aluminum 28% silicon and aluminum 10% Mg master alloys. These in the suitable proportions, these were placed in the graphite crucible, and the help of muffle furnace melting was done. Once the molten metal is obtained of the desired temperature, the molten metal is poured into the metallic mold under the gravity. So metallic mold like this of size 25 150 mm length. So 150 mm length and 25 square section, 25. Okay. Then a hypoeutectic and eutectic aluminum alloys were refined or treated using the strontium for modification, and the strontium was used in form of the aluminum 10% strontium master alloy, and a hypereutectic silicon alloy was modified with the addition of 0.01% of the phosphorus. Okay. and these 3 aluminum silicon alloys, okay, say 12% silicon and say 18% silicon, these were then prepared for microstructural study using the standard metallographic procedure. What is that? The other things will be initially they will be doing the grinding. After grinding, the things will be polished using the finer grade papers, and then the polishing will be done using cloth, and after the polishing is done, these samples were etched with the Kahler reagent, and using the optical microscope microstructure study was performed. Hardness was studied using the Vickers hardness test at a load of 5 kg to study the effect of silicon content on the hardness. So, if we see here the microstructure of aluminum 4% silicon 0.3% Mg, what it shows? Predominantly alpha aluminum. Okay. So, the light in color like white color is the alpha aluminum. It is a very fine dendrites of alpha aluminum. Okay. And like say very little amount of the dark eutectic of aluminum and silicon, because predominantly it is having alpha aluminum. Why? Because the aluminum for this is aluminum 0.44% silicon and 0.3% Mg. Eutectic is formed at 12% silicon, therefore, it is primarily having the alpha aluminum with the very less amount of the eutectic in the interdendritic zones. And these dendrites are extremely fine. Why? Because the very high cooling rate is offered by the metallic mold. Okay. If we talk of the aluminum 12% silicon and 0.3% Mg, then you will see this corresponds to this alloy corresponds to the eutectic alloy. So, here predominantly this is having the eutectic matrix. So, that is having why? Because so this matrix is about say 80 to 90% eutectic and like say 10 to 20% of the alpha aluminum. Predominantly this is having the eutectic matrix. So, whatever the alpha aluminum is available in form of the dark shade, the dark one is the eutectic matrix and the light color is of the alpha aluminum. So, this alpha aluminum again is of very fine dendritic structure, very fine, having the very small dendritic arm spacing, that is what we can see, and this is happening due to the very high cooling rate being offered by the metallic die that was used for the development of these castings. If we talk of the aluminum 18% silicon alloy, then this is primarily having the eutectic matrix and presence of the primary silicon particles. So, these polyhedral shape primary silicon particles, whenever these are visible, that indicates that this is corresponding to the hyper eutectic aluminum silicon alloy. Presence of primary silicon particles in the eutectic matrix indicates that this is a hyper eutectic aluminum silicon alloys. Since silicon is hard and brittle as compared to the aluminum, therefore, increasing the silicon content, say for 4% hardness is 70 VHN, for 12% of silicon it is 98 VHN, and for 20% silicon it is 138 VHN. Okay. This is why this is happening, because of the increasing silicon content, increasing the hardness, because silicon itself is hard and brittle in. So, now we will see how we can estimate the proportion of the different constituents. So, for that we have to see this aluminum silicon phase diagram. This is binary phase diagram of aluminum and silicon. Okay. So, the eutectic is formed here at 557 degrees centigrade. Okay. Pure aluminum is say melting around 662 or say round about 660 degrees centigrade. Okay. And for silicon it is 14 degrees centigrade. Okay. So, here 100% aluminum and here this side other side 100% silicon, and eutectic is formed at let us say 12.6% of silicon. Okay. So, now we know that say there is aluminum 20% silicon. So, that this is the Ly composition corresponding to the 20%. Okay. So, here what we can see here, this side we have eutectic and other side we have primary side we have the silicon. So, if we see the kind of the phase transformation that will be happening here on cooling, the hyper eutectic aluminum silicon Ly on cooling, what it will be producing? Predominantly it will be producing the eutectic silicon that will be corresponding to this length. Say if this is say A, B and C. Okay. So, as per the lever rule, after the eutectic reaction, after cooling down below the eutectic temperature, what will be happening, right? Percentage of the eutectic will be how much? Percentage of the eutectic will be A B divided by B C. Okay. So, A B is how much? 100 minus say 20 divided by 100 minus 12.6. This is how we can determine the percentage of silicon, and balance will be the primary silicon particle. Okay. Similarly, if we want to determine the, in case of the 4% silicon, then we have to consider this case. So, in that case, this will be the fulcrum of our corresponding to the lever rule, and here, so this is A, this is B and this is C. So, B is corresponding to the eutectic composition, C is corresponding to the alpha aluminum, that is corresponding to the solubility of the silicon, 1.6% of silicon in aluminum, and this is say corresponding to the 4% silicon. So, if you want to determine the percentage of alpha aluminum, then percentage of alpha aluminum will be equal to AB divided by BC. So, AB is how much? 12.6 minus 4 divided by 12.6 minus 0.16. So, this will be giving us the alpha aluminum on, and the balance will be the eutectic, which will be very less. Okay. And if we are interested to determine the proportion of various phases, like say the silicon and alpha aluminum in eutectic mixture corresponding to the 12%, then we can, that also we can determine. Say for aluminum 12% silicon, what will be having? So, this side the silicon and other side alpha aluminum in eutectic silicon, assuming that there is a 100% aluminum silicon eutectic. Okay. So, what is the proportion of aluminum and what is the proportion of the silicon in that? That is what we can determine. So, here A, B and C. So, for alpha aluminum in eutectic, we can determine from the AB divided by BC. Okay. So, what is that? 100 minus 12.6 divided by, or here we can say 12, or then yes, 100 minus 1.6. So, this will be giving us the proportion of the alpha aluminum, and balance will be the eutectic one. So, if we see using the lever rule and with the help of phase diagram for a given aluminum silicon alloy composition, we can determine the proportion of various phases for a given composition of an alloy. If we try to see the effect of silicon in aluminum and very characteristics of the aluminum silicon alloys, then what we can see here, with the increasing silicon, the ductility comes down very rapidly. This is happening due to the formation of the formation of the needle shaped eutectic silicon, that is one, and the silicon is hard and brittle. On the other hand, it increases the hardness, it increases the strength, it improves the fluidity. It also improves the hot resistance to the hot cracking. Why? Because our solidification temperature range is reduced with the addition of the silicon. Okay, around 1%, certainly for 1.6 it is maximum, but then it is decreasing, the solidification temperature range is decreasing, and then only we will be seeing the reduction in the hot cracking tendency. Similarly, the wear resistance is also enhanced with the increase of the silicon. Another interesting thing which is very important for making the aluminum silicon alloy for automotive applications is the drop in thermal contraction or the expansion coefficient. So, thermal expansion coefficient of the aluminum silicon alloy decreases with the increase of the silicon, and that is why it is found to be very useful. So, there are two things. One is the reduction in the hot cracking tendency and improvement in fluidity. These make the aluminum silicon alloy very easy to cast. Actually, when the silicon content is higher, especially around 8 to 12%. This makes the casting very easy when we use the aluminum silicon casting alloys. So, here now we will summarize this presentation. In this presentation, what we have seen, like how to prepare the patterns using the wood, how to prepare the molds, and how to make the castings. Then also we have seen one case study where we have tried to see the effect of the silicon on microstructure and mechanical properties. Thank you for your attention.